everybody, welcome back. This is CHEM300 and we're continuing chapter 6 today with counting molecules by the gram. So our goals in this section are to define atomic mass, molecular mass, and formula mass. We've covered all these before. We're going to do a quick review. Then we're going to define and calculate the molar masses for compounds. We're going to perform conversions between mass and moles of a compound, and we're going to perform conversions between mass and number of particles of a compound. So in the previous section, we were talking about these conversions using Avogadro's number and molar mass with elements. We're going to apply the same principles, but now instead of applying them to individual elements, we're going to be applying them to whole compounds. So another chemistry meme for you here today. What do you get when you cut an avocado into 6 × 10⁻23 pieces? Guacamole? Okay. At least I humor myself, right? Okay, so let's do a little review about molar mass and other types of masses. So for compounds, when you have more than one type of atom, the molar mass is the mass of 1 mole of molecule or formula units of that compound. So molecular compounds exist as individual molecules. So the molar mass of a molecular compound is the mass of 1 molecule of that compound. And ionic compounds don't contain individual molecules. They exist as that repeating array of positively and negatively charged ions. So the molar mass of an ionic compound is the mass of 1 formula unit. And just like we did with individual elements, we're going to use the molar mass of compounds as a conversion factor to go between grams of compound and moles of compound. So here's our quick review of all the different ways we know how to calculate masses. So we have atomic mass. That's the mass of 1 atom of an element. It's reported in atomic mass units, AMUs. This is what you read off the periodic table for each of the elements. The molecular mass. This is the mass of 1 molecule of a molecular compound. It's also reported in units of AMUs. Formula mass. This is the mass of 1 formula unit of an ionic compound. Also reported in units of AMUs. And then molar mass. This is the new one we introduced in chapter 6. This is the mass in grams of 1 mole of a substance. It has units of grams per mole, which we oftentimes just write as G/M, grams per mole. The molar mass is numerically equivalent to all the other above masses. So if you look up the atomic mass of an element on the periodic table, its molar mass is the same number, just with the units changed. Instead of in units of AMU, when you're talking about a molar mass, it'll be in units of grams per mole. Same thing for molecules. You calculate their molecular mass, and then you simply change the units to grams per mole, and that will give you the molar mass. And again, for ionic compounds, calculate their formula mass using the masses of the individual atoms in the compound on the periodic table. That's in units of AMU, and then you change the units, but keep the number the same in order to convert it to the molar mass. So let's calculate the molar mass for a compound. Let's calculate the molar mass as well as the molecular mass for ethanol, CH3CH2OH. So these are going to be the same number, just the units are going to be different. Molecular mass, AMUs, molar mass is going to be in units of grams per mole. So to calculate the molecular mass, we'll do that first because we're going to use the atomic masses in the periodic table in units of AMUs. We'll get the molecular mass for the whole compound, and then we'll convert the units to grams per mole to report the molar mass. So to figure out the molecular mass, we've got to take the masses of each of the types of atoms in the compound and multiply it by the number of atoms present. So we have carbon. We have 2 atoms of carbon, and its atomic mass is 12.01. 01 AMU. Hydrogen, we have 3, 4, 5, 6 total atoms of hydrogen, and the molar atomic mass of hydrogen is 1.01 AMUs when rounded to the hundredths place. And then oxygen, we have 1 atom of oxygen, and its molar mass is 16 when rounded to the hundredths place. So let's do the multiplication steps first. It'll make it easier to follow the rules for sig figs when we add these up at the end. So I get 24 0.02 AMUs with 4 sig figs. I get 6.06 AMUs with 3 sig figs, and then 16 with 4 sig figs. So now we want to add all these up to get the molecular mass. And notice that they all have their last sig fig in the hundreds place. So our final answer is also going to have its last sig fig in the hundreds place. So I get 46.08 AMUs. So this is the molecular mass of ethanol. So that's the first part of the question. Calculate the molecular mass. And now to calculate the molar mass, we're going to keep the number the same, 46.08, and we just change the units. Now it's grams per mole, and that's the molar mass of ethanol. For the second part of the answer. So again, to figure out molar masses for compounds, you first find the molecular or the formula mass, and then you convert the units to grams per mole, but the number stays the same. So let's do some conversions using molar masses of compounds and ionic of compounds to do some of these conversions like we did previously in the previous section with elements. So how many grams of water are contained in 5.69 moles of water? So we're given that we have 5.69 moles of water, H2O, and we want to find grams of water. So we're going to start with moles. We need to convert to grams. And anytime we're going from moles to grams, or if we were given the grams and wanted to go to moles, anytime you're converting between those two, you use the molar mass. So the molar mass of water, just abbreviate that MM, is the mass of 2 hydrogen atoms plus the mass of 1 oxygen You add those together, you get 18.02 AMUs. That's the molecular mass. And to turn it into a molar mass, we just change the units. So 18.02 grams per mole. Okay, so now that we have all the pieces we need, let's solve this. We're going to start with our 5.69 moles of water. And we're going to use the molar mass as our conversion factor to convert to grams. So we want to cancel out moles and end up with grams. So when we use our molar mass, we're going to set it up so moles are on the bottom. So for every 1 mole of water, that weighs 18.02 grams. And if we check our units, moles of water and moles of water cancel, we're left with just grams, which is what we wanted to find. Okay, so let's plug it in. 5.69 times 18.02 gives me 102.5338 grams of water. This is my unrounded answer, so we want to always check our sig figs. We have 3 sig figs there. We have 4 sig figs in our molar mass. So we're going to round our final answer to 3 sig figs. So for final answer, that 2 is going to round up to a 3. You get 103 grams of water. And if we want to make sure this conceptually makes sense, we have just over 5.5 moles of water. And each mole of water weighs 18 grams. So if you take 18 and multiply it by about 5, I would say that's around 100, because 20 times 5 is 100. And we got around 100 grams, so that makes sense. Okay, let's do another one. So this is grams to number of units of a compound. So how many moles of calcium chloride are in 50.75 grams of calcium chloride? So we're given that we have 50.75 grams of calcium chloride, and we want to find moles of calcium chloride. So our plan is to go from grams to moles. And anytime you're going from grams to moles or from moles to grams, we use the molar mass as our conversion factor. So we need to figure out the molar mass of calcium chloride. So we'll do that calculation over here. Molar mass CaCl2. So we have calcium. We have one atom of calcium, and that weighs 40.08 AMUs. And for chloride, we have two atoms of chloride, and they each weigh 35.45 AMUs. I'm not going to try doing that in my head at the moment, so let's just plug that in. 70.90. And do a quick sig fig check. I've got 4 here, so I want 4 there. And I've got 4 here, so I want to keep all 4 there. When you plug this into your calculator, 35.45 times 2, it's going to spit out 70.9. But you have to recognize, because there's 4 sig figs in your atomic mass, you need to include 4 sig figs when you multiply it by 2. Okay, we're going to add those up. Plus 40.08. And I get 110.98 AMUs, which we know is going to be numerically the same for the molar mass, but now it's in units of grams per mole. So now we have everything we need to solve this problem. We have our starting value, we have our conversion factor, and we'll be able to find moles. So we have 50.75 grams of calcium chloride times, this is where our molar mass conversion factor comes in, and we want to end up with units of moles and convert out of grams. So we're going to put 110.98 grams of calcium chloride for every 1 mole of calcium chloride. Molar mass is a conversion factor, so if you need to flip this ratio to use it properly as a conversion factor, you can do that. Let's do a units check. Grams of calcium chloride and grams of calcium chloride cancel out. We're going to be left with just moles. That's what we wanted to find. So you can do your trademark smiley face. Okay, so 50.75 divided by 110.98 gives me 0.45728 moles of calcium chloride. And we need to check sig figs. So we've got 4 sig figs in our starting value. We have 5 sig figs in our molar mass. So we're going to end up with 4 sig figs in our final answer. So I end up getting 0.4573 moles of calcium chloride. You always want to put a box around your final answer so they're nice and easy to identify. And then do a quick check. Does it make sense? Well, we started out with about 50 grams of calcium chloride, and 1 mole of calcium chloride is just over 100 grams. So if we know that 1 mole is about 100 grams, if we only have 50 grams, we expect about half of a mole, which is what we ended up with, about half of a mole. So it makes sense. It's a good way to check that you didn't accidentally mess up one of your conversion factors, or that you didn't have like a calculator mistake where you punched something into your calculator incorrectly. Okay, so putting it all together, we talked about nails at the very beginning of chapter 6, weighing things by counting them using that hardware store example. So if you weigh something in pounds of nails, you can convert that to dozens of nails using a conversion that relates the mass to the counting unit of dozens. And then you can relate dozen to the precise number of nails, individual nails. In chemistry, we follow the same process, right? We weigh out our grams of atoms or compound in the lab. And then we use the molar mass as a conversion factor to convert to moles. Moles is kind of like the chemist's dozen. It's our counting unit. And then to go from moles of atom or compound to the numbers of atoms or units of a compound, we use Avogadro's number. That's kind of relating that for every 1 dozen nails, for every mole of atom or compound, it equals that number of individual nails. For Avogadro's number, 1 mole of atom or compound equals 6.022 times 10 to the 23rd individual particles. Okay, so this is a big example. It's going to be a long one, so we're going to do this on a whiteboard. This asks how many formula units of ethanol, CH3CH2OH, are in 47 milliliters of ethanol. The density of ethanol is 0.79 grams per milliliter. So we're starting with a volume of ethanol. We're going to have to use the density to convert that volume into grams. And then once we're in units of grams, we're right here. We can take our grams of our molecule of ethanol, convert it to moles, and then convert moles to number of molecules of that compound. Okay, so let's open up a whiteboard. I'll copy and paste it over. New whiteboard. Okay, here we go. There's our problem. So let's plan it out. Let's identify our given. (47 milliliters of ethanol. And we were given the density, 0.79 grams per milliliter of ethanol. And we want to find formula units. So it's the same thing as number of molecules. Okay, so let's make out a plan. We started with milliliters, right? Density is a conversion factor, so we're going to use that at some point to convert between volume and mass. So we're going to start with our given milliliters of ethanol. We eventually want to end up with number of molecules, which means at some point we're going to need to use Avogadro's number, which relates number of molecules and moles. But we can't go straight to moles from milliliters. We've got to get it to grams. And then once we're in grams, we can go to moles using the molar mass of ethanol. So we're going to take milliliters to grams using the density as our first conversion. The density tells us how many grams are in 1 milliliter of ethanol. So we could use that to convert from our given milliliters to grams. And then once we're in grams, we can use molar mass to convert from grams to moles. And once we're in moles, we can finally use Avogadro's number to convert from moles to number of molecules. Okay, so we know the density was given to us. We know Avogadro's number. It's always 6.022 times 10 to the 23rd particles per mole. In this case, our particles are number of molecules. So we need to calculate the molar mass based on the formula for ethanol. So let's do our molar mass calculation down in this corner. Actually, we'll do it up here. Molar mass CH3 CH2OH. So we have carbon, and we have 2 atoms of carbon. So 2 times 12.01. We have hydrogen. So 3, 4, 5, 6 atoms of hydrogen, 6 times 1.01. And we have oxygen. We have 1 atom of oxygen times 16. So let's see what each of these are. Again, this is my carbons, my hydrogens, and my oxygens. So 24.02 AMUs for my carbons, 6.06 AMUs for my hydrogens, and 16 AMUs from the oxygen. So I need to add these all up to get my total molecular mass. And I get 46.08 AMUs. If we check our sig figs, we had 4 here, so we get 4 there. We had 3 here, so we get 3 there. We had 4 and 16, so we get 4 there. So when I add these up, my final sig fig in each of the values I'm adding is in the hundreds place. So my final sig fig and my final answer is going to also be in the hundreds place. So now that we have the molecular mass in AMUs, the molar mass is that same value, but in grams per mole. So 46.08 grams equals 1 mole of ethanol. That's our conversion factor between grams of ethanol and moles using the molar mass. We'll figure out what ratio, how we want to set it up as we put the problem, solve the problem and see what we need to cancel out. So let's work on solving it. So let's start with our milliliters. We have 47 milliliters of ethanol. Just going to abbreviate that ETOH for ethanol. We're going to use the density to convert milliliters to grams. So when we use the density to convert milliliters to grams, we want the milliliters part of the density on the bottom. So we're done with that part. Now we want to convert our grams of ethanol to moles using the molar mass. So we want to set up the molar mass so that grams cancels out and we're left with moles. So we want the mole part on top, 1 mole of ethanol weighs 46.08 grams. Okay, so we did that part. And now we need to use Avogadro's number to convert our moles of ethanol to number of ethanol molecules. So for Avogadro's number, we want the moles part on bottom and the number of particles. In this case, our particles is a molecule on top. 6.022 times 10 to the 23rd ethanol molecules. Okay. I'm going to check all my units before I take the time to put that in my calculator. We've got 47 milliliters, so milliliters and milliliters cancels out. Grams and grams cancels out. Moles of ethanol and moles of ethanol cancel out. And the only thing we have left is number of ethanol molecules, which is what we wanted to find. Okay, so now I'm going to plug it in. So 47 times 0.79 times 6.022 times 10 to the 23rd. On my calculator, what I do at this point is I hit the equal sign. So I multiplied everything together on the top, hit the equal sign. Then I hit the divide sign. And in parentheses, I multiply everything together on the bottom. So it's just 46.08 times 1 times 1. And so I get, for my number of ethanol molecules, 4.85236 times 10 to the 23rd molecules. We have to check sig figs. So we only have 2 sig figs in our starting value. We have 2 sig figs in our density. We have 4 in our molar mass, and we have 4 sig figs in Avogadro's number. So we're going to be limited to 2 sig figs in our final answer. So we've got to do a little bit of rounding to get 4.9 times 10 to the 23rd ethanol molecules. Okay, and actually how I got this number, I made this problem up. I make my own beer at home. I'm an avid home brewer. It's a cool way to apply chemistry. 47 milliliters of ethanol. That's about how much ethanol is in a 22-ounce home brew of like a strong IPA. So now I know when I drink one of my strong IPA home brews, I'm drinking about 4.9 times 10 to the 23rd molecules of ethanol. Okay, so that's the end of this section of chapter 6. In the next section, we're going to cover using chemical formulas as conversion factors. I'll see you then. Let me know if you have any questions. Bye, everybody.